Okay. A 0.6 meter string vibrates. Oh, and let's assume it's fixed at both ends. I forgot to put that in this question. So it's fixed at both ends. It has a fundamental frequency of 125 hertz. What is the speed of the wave through the string? Okay, so we know our frequency is 125 hertz. We know the length of the string, not the wavelength, but we know the length of the string is 0.60 meters. Now, it's a string that's attached at both ends and has a fundamental frequency. So what does that look like? It's going to look like this. Okay, spring, string, doesn't matter. So it has a fundamental frequency. So that means that our string looks like this, where this length is equal to 0.60 meters. But how much of a wavelength is this? Half. So this is half of a wavelength. So our L is equal to half of a wavelength.
Why is it a half now?
Oh, because here, had it. Here. So when we had our closed tube, that's only a quarter. But a fundamental frequency, when it's vibrating in that, I don't know. How did we know it was a half, Rael? Because it's a full half of a wavelength, right? From here to here, if we looked at this wave, and then it goes up, this whole thing is 1/2. It was that when we looked at the fundamental frequency that's resonating, that's only a quarter.
He told me he doesn't understand that.
This is only a quarter of a wavelength, right? It's like we cut it right there, and that's where we heard the resonance of the tube. But here, since it's a spring or a string, oh my gosh, I'm having a hard time with this today.
I think I understand.
Yeah?
Yeah, it doesn't seem.
I get, your question is probably because they're both fundamental frequencies, right?
Yeah.
Yeah, but this is just, we have that fundamental frequency, it's different because it's a different medium. Different.
Same but different.
Yeah.
If it's fixed at both ends, is it always?
Good one. Okay, good. Rachel made a good observation. She said, if it's fixed at both ends, fundamental frequency is half. Yes. Fixed at both ends, fundamental frequency is half. If it's open at one end, fundamental frequency is a quarter. Good observation. Okay, so we have two formulas. We have our L is equal to wavelength over 2, or L is equal to 1/2 of wavelength, okay? That's kind of what we made. So this is going to be our first calculation, because we need that wavelength in order to find the speed. So we go, what am I doing here? I'm finding wavelength. So that's equal to 2 times L. So my wavelength is 1.20 meters. So now I have wavelength and I have frequency. Now I can find the speed using my universal wave equation. So my second step, V is equal to wavelength times F. V is 1.20 meters times by 125 hertz. So V is 150 meters per second. Am I going too fast?
How did you get 2L?
Oh, that was when I drew my spring and I said, this is half of a wavelength, but I know the length. So I say this is half of a wavelength is equal to the length. So it was like I made this formula where I said L is equal to a wavelength divided by 2. I rearranged to solve for this by just cross multiplying. Yeah.